Hey guys, welcome to Simply Electrical. We're going to talk about range calculations according to NEC 220.55. This video is for 2023, but it's good for all code cycles currently in use. There are some additions to the notes in table 220.55, but they're fairly minor and they don't apply to range calcs, only to range branch circuits, so they don't affect us here. This is a deep dive video, so we're going to take our time to go through each step in detail so that any questions you might have will be answered. Since this is a long video, feel free to use the timestamps to jump to content that is relevant to your situation. Now here's a map that's put out by the NFPA showing which editions of the NEC each state was under as of March 1st, 2024. Now you can see that only 8 states have adopted the 23 code so far. 27 states are still under the 2020 edition, and 11 states are on prior code cycles. And then there's 4 states that adopt the NEC at local levels rather than statewide. Now I'm here in Texas, so I'm under the 23 edition. Always be aware of what edition you're under for your neck of the woods. Okay, so here's 220.55. And you'll notice this little triangle over here on the left side, and that tells us that there's a change that has been implemented in the 23 code. But like I said before, it doesn't apply to us, it doesn't affect feeder calcs, it's just in the notes to the table, and we'll talk about that when we get there. So let's go ahead and read this text. 220.55, electric cooking appliances in dwelling units and household cooking appliances used in instructional programs. All right, so the load for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances individually rated in excess of 1 3/4 kW shall be permitted to be calculated in accordance with table 220.55. Kilovolt amperes, kVA, shall be considered equivalent to kilowatts for loads calculated under this section. So that last sentence there is pretty simple. It's just saying you can use kVA and kW interchangeably in these load calcs, and that's what they're going to do. We're going to save this second paragraph for later because it deals with 3-phase systems, and so we'll talk about that on its own for the last portion of the video. So now in most cases here, I'll be using the term ranges as an abbreviation to apply to all household cooking equipment unless otherwise noted, because saying this phrase every time is a mouthful. Now this is kind of the standard in the industry when discussing 220.55. We use the term range kind of as an overall and all-encompassing term to include all the cooking equipment in the kitchen. But don't worry, I'll make it clear when a differentiation between ranges and other cooking equipment is necessary. Okay, now here is the entire table, 220.55, but we're going to zoom in so you can see it a little bit better as we go through it. So the table is fairly simple. But it does get a little bit complex when we get into the notes and the different ways this can be applied. So let's go over how it's laid out first of all. Up here it says table 220.55, demand factors and loads for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances over 1 3/4 kW rating. Okay, now that's important. It says over 1 3/4, so any ranges under 1 3/4 kW will not apply to this table. They have to be taken at 100%. Okay, we'll come back to this parenthetical statement here in just a minute. Let's first look at the table and see how it's laid out. So you have these 4 sections here, columns, but really you have 3 main columns, A, B, and C. The first column over here is just your number of appliances that you're dealing with. So then you have column A, which says less than 3.5 kW rating. Now that's a little misleading because we were already told that this table only goes down to 1 3/4 kW, so this really should have said between 1 3/4 and 3.5 kW rating. I'm not sure why it says less than 3.5. That's, like I said, a little misleading. And then column B says 3.5 kW through 8 3/4 kW. So that's pretty simple. You got 1 3/4 through 3.5, and then 3.5 through 8 3/4. And then you have column C, which says not over 12 kW rating, but it tells you to see the notes, and it tells you that this is maximum demand. So the difference between A, B, and C, and this is very important to recognize, A and B are demand factor percentages. So this is 80%, 75%, and so on. Same with column B, 80, 65, 55, and so on. However, column C is not a percentage. This is a kW demand rating. So this is 8 kW, 11 kW, and 14 kW, and so on. Now this is very important, especially as you get further down the columns. I stopped here at 5 just so I could zoom in. But as you get further down, you're going to have some situations where your number here is the same as your number here or very similar to it, and that can really mess you up. If this says like 32 and this says 30, that's 32%, and this is 30 kW. And if you get those mixed up and you put 30% and 32 kW, it can really mess up your calculation if you're doing this for an exam. So that's just something to take note of. This is kW rating, and these two are percentages. Very important. Okay, now we're going to go back up to here to this parenthetical statement here. It says column C to be used in all cases except as otherwise permitted in note 3. And we'll get to note 3 in just a second. But it's telling you that you're supposed to use column C in all cases unless you have specific permissions to use it by note 3, which we'll talk about column A and column B and when you can use those. So here's note 3, and this is found at the bottom of the table in the code book. It says over 1 3/4 kW through 8 3/4 kW. All right, so we're told that anything between 1 3/4 and 8 3/4, which is basically column A and column B. That's what those two columns cover. All right, it says in lieu of the method provided in column C, adding the nameplate ratings of all household cooking appliances rated more than 1 3/4 kW, but not more than 8 3/4 kW, and multiplying the sum by the demand factors specified in column A or column B for the given number of appliances shall be permitted. Okay, let's stop right there for a moment and talk about what that means. What it's saying is you have to use column C in any case unless your situation falls within these parameters here. If you have ranges over 1 3/4 kW and under 8 3/4 kW, you can use the appropriate column here that they fall under. So what you will do is if you have one range at, let's say you have a 3000 watt range, so a 3 kW range, you have one of them, you will take 80% of that 3000, which gives you 2.4 kW, and that'll be your answer. So that means if you have 4 ranges, you would add them together and then you would take 66% of that number, and that would give you your value. Okay, so that's pretty simple. Now if you had, let's say, 5 kW ranges, then you'd use column B because it falls between 3.5 and 8 3/4. So let's say you have 5 of those. You would take 5 times 5,000, and then you would take 45% of whatever that number is. And that would be your final demand. Okay, so that's actually pretty simple. Now let's go on to the second sentence. It says where the rating of cooking appliances falls under both column A and column B, the demand factors for each column shall be applied to the appliances for that column and the results added together. So let's say you had 2 from each. So you had 2 that landed in column A and 2 that landed in column B on the same feeder. Well, then you would treat these separately. You take the 2 here, you'd add them together, then you multiply by 75%, and then you take the 2 that fall under column B, add them together, and multiply them by 65%, and then you would add those 2 answers together to get your final demand. And that's all that's saying. So in a nutshell, note 3 simply says that if you have ranges that fall into either of these two categories, A or B, you can use these columns for your calculation. Otherwise, you must use column C. Now we'll see what a difference it can make as we go through our examples here. Okay, let's start with one range at 9,000 watts. If we plug it into the table, we have one range, and we must use column C because it's over 8 3/4 kW, but under 12. So we would have a value of 8 kW, also known as 8,000 watts. Even though our actual connected load is 9,000 watts, our calculated load is only 8,000 watts. This is a good time to talk about these two terms. Connected load refers to the actual rating of the appliances. In other words, it's what's actually connected to the circuit. Calculated load refers to the adjusted load after demand factors have been applied. In other words, what you get after calculations are done. It's important to keep these terms clear in your mind. Now, if we had a 12,000 watt range, our connected load Again, we land in column C and arrive at 8,000 watts for our calculated load. So both a 9,000 watt and a 12,000 watt range each get calculated at 8,000 watts. Now that seems weird to most people that see this for the first time. Now that's a single range in column C, and that's about as easy as it gets. But what if you had more than one? Let's now take 4 ranges at 9,000 watts apiece. Instead of 36,000 watts, which is what we would get if we added them all together, we use a table and we get 17 kW. So you see that we are allowed a substantial reduction with the ranges when we bundle them together on a feeder. But let's see it even more. Here we have 4 12 kW ranges, yet we still get 17,000 watts. That's instead of the 48,000 watts of connected load. So here we see that multiple ranges are about as easy as a single range if they all land in column C. And you can also see how substantial the savings is on our kW by using the table as opposed to just adding up the nameplates for each of these sets. Now let's look at some examples of ranges that fall into columns A and B. If we have a 3,000 watt range, we go to the table and we have one range. 3,000 watts lands us in column A because it's less than 3.5 kW, which will apply an 80% demand factor, giving us 2,400 watts. But if we have an 8,000 watt range, that puts us in column B, since it's between 3.5 and 8.75 kW. This also happens to apply an 80% demand factor, which gives us 6,400 watts. So using the table to calculate a single range is quite easy, no matter which column it falls under. And if we have more than one range, it's not much different. Now let's look at 4 ranges. We've got a 2,000, a 3,000, a 2,500, and a 3,250 watt range. Adding the nameplate ratings of the ranges together, we get 10,750 watts. In the table, we have 4 ranges. All 4 ranges fall into column A because they're all under 3.5 kW, which allows a 66% demand factor. Now 66% of 10,750 is 7,095 watts. Next, we'll try 4 more ranges at 3.5, 6.5, 5, and 8 kW. Add them up and we get 23 kW just off the nameplate. But going back to the table, we see that we need to take 50% of the total to get our demand. That means half of 23,000, which is 11,500 watts. So that's about as easy as calculating just one range with the additional step of adding the ranges together before applying the demand factor. So all in all, so far, using this table 220.55 is pretty easy. Now let's consider what happens if some of the ranges fit into column A and some land in column B. Here we have the same 8 ranges from the previous slide, but now we're going to put them all on one feeder. So 4 of them are in column A and 4 in column B. And if you remember, the second sentence of note 3 tells us where the rating of cooking appliances falls under both column A and column B, the demand factors for each column shall be applied to the appliances for that column and the results added together. So we have to take each group according to the column it falls in. Then, after applying the corresponding demand factors, add the 2 group totals together. Therefore, we add the first group together to get 10,750 watts. Add the second group and get 23,000 watts. Then we go to the table. We have 4 ranges in the first group, which gives us a 66% demand factor. 66% of 10,750 is 7,095 watts. We also have 4 ranges in the second group, and so apply 50% to it, and that gives us 11,500 watts. Once we have these 2 demand totals, we simply add them together and get 18,595 watts. And that is our calculated range load on the feeder. Now you can see how if we had just added the range values straight up, we get a much higher total value, 33,750 watts. So once again, it's evident what a major effect the demand factors have on the result. Therefore, it's very important to do these calcs correctly, especially for an exam. That about does it for the typical scenarios. Now let's look at some less usual situations. Okay, you remember at the beginning of the video that I explained how I've been using the term range as an abbreviation for all cooking equipment? Well, now we have to make a distinction. Notes 1 and 2 of table 220.55 apply specifically to ranges only and not to other cooking equipment. So for the remainder of the discussion of these two notes, we will be talking about ranges only. Column C restricts its use to ranges not over 12 kW. You may have wondered about ranges that exceed 12 kW rating. Well, that's where notes 1 and 2 come into play. The main difference between the two notes is that note 1 for the ranges of equal ratings and note 2 is for those of unequal ratings. The other difference is that note 2 includes ranges down to 8 3/4 kW instead of starting at 12 like note 1 does. But we'll talk about that later. Let's look at note 1 first. Okay, note 1 says over 12 kW through 27 kW ranges all of the same rating. Okay. For ranges individually rated more than 12 kW but not more than 27 kW, the maximum demand in column C shall be increased 5% for each additional kilowatt of rating or major fraction thereof by which the rating of individual ranges exceeds 12 kW. Okay, the first thing to consider is that this note only applies to those ranges over 12 kW through 27 kW, and only those that have the same rating. That's key. So if your range is 12 kW or less, you would use column A, B, or C, depending on where it falls. If your range is above 27 kW, you must take it at a nameplate rating because the NEC doesn't address any exceptions for such sizes. So anything over 27 kW, you have to take it at nameplate. This table does not apply. Okay, now to make this easy, I put this into a formula. That way you can just plug in your data and have your answer in a matter of seconds. So the C here stands for the column C value. So these values over here. And then the KW refers to the KW rating of the individual range. And the total is your calculated total with your demand included. So let's take one range with a 13,000 watt rating. Now the table tells us that one range would be calculated at 8 kW. But since it's over 12 kW, we have to increase it accordingly. Now our handy dandy formula will make quick work of it. Our column C value is 8 right here. And so we plug in 8 to the formula. Wherever we see the C, we plug in 8. And our KW rating is 13 because the individual range is 13,000 watts. So we plug in 13 here. And when we compute it out, we come up with 8.4 kW as our answer. And that is our calculated load. So it's actually pretty simple once you have the formula. But let's try 4 ranges. And these are each 13,000 watts apiece. Okay, so we go to the table for 4 ranges. And we would get a demand factor of 17. Plugging those numbers into the formula, we have 17.85 kW for our calculated load. And that is how note 1 is implemented. It's as simple as that. Next, we're going to dive into note 2. First, let's read it. This says over 8 3/4 kW through 27 kW ranges of unequal ratings. Okay, for ranges individually rated more than 8 3/4 kW and of different ratings, but none exceeding 27 kW, an average value of rating shall be calculated by adding together the ratings of all ranges to obtain the total connected load. And now this is the tricky part. Using 12 kW for any range rated less than 12 kW, and then dividing by the total number of ranges. Okay, let's stop right there. In a nutshell, it's attempting to accomplish something similar to note 1, but through averaging. Here is the formula I've drawn up for note 2. Notice that it contains the same formula as note 1, but has an additional preliminary step to it. Since we have unequal ratings, we have to average them out before applying them to the formula. So let's start with 4 ranges above 12 kW as an example to work through. We have a 13, 15, 21, and 23 kW range. Adding them up, we get 72 kW. To get the average size range, we divide by the number of ranges, which is 4. This gives us 18 kW as our average. We'll use that number in the formula, just like we did in note 1. But first, we have to go to the table to get our demand for 4 ranges. and we find that it is 17 kW. Now that we have both numbers needed for our formula, we can simply plug them in. We plug in the 17 here from column C, and we plug in the 18 here from our kW average. And we end up with a 22.1 kW calculated load. So that works out pretty well. We see that our total comes to be several kW higher than our column C value of 17. And that's exactly what we would have expected. Okay, the tricky part of note 2 is remembering to substitute the value of 12 kW for any range that is rated between 8 3/4 and 12. Let's work through another example to see how this plays out. We have 4 ranges at 9, 10, 11, and 16 kW. Adding these up gives us a connected load of 46 kW. If we took them at face value, we would end up with an average of 11.5 kW. But that would be a mistake. This parenthetical clause up here tells us that we need to treat this problem a little differently. Any of our ranges that are less than 12 kW need to be valued at 12 kW before averaging takes place. So that's critical. So now we see we got 12, 12, 12, and 16, and that gives us a total of 52 kW. Divide that by 4 and we get 13 kW. Now we go to our table. We have 4 ranges. It gives us 17 kW. And now we have our 2 numbers we need. We have our kW and we have our C column value. Now we can plug those into the formula and we get 17 plus 17 times 13 minus 12 times 0.05 equals 17.85 kW. And that is our calculated load. So just don't forget to value any range under 12 kW as 12 kW, and you'll be all right. Okay, now we've gone over notes 1, 2, and 3 because those are the only notes that apply to a service or feeder calc. The rest of the notes for table 220.55 are mainly for branch circuits and don't apply to load calcs. So we are not going to talk about notes 4, 5, 6, and 7. Now we're going to go back to the text of 220.55 and consider the second paragraph that we skipped over before. It says, where 2 or more single-phase ranges are supplied by a 3-phase, 4-wire feeder or service, the total load shall be calculated on the basis of twice the maximum number connected between any 2 phases. Remember, this is for ranges only. This is not addressing other cooking equipment. Don't make the mistake of including cooktops or ovens in this part. Okay, this sentence sounds easy enough, but what does it actually mean? How do we find the maximum number of ranges connected between any 2 phases? Well, first, let's get a visual of how these ranges are connected to the feeder. Here we have 9 single-phase ranges connected to a 3-phase feeder. You can see each phase, A, B, and C, and each connection point. These are equally balanced because code requires you to balance your loads across phases as much as possible. Because they are single-phase ranges, they each only connect to 2 of the 3 phases. And we can see from this drawing that phase A and B have 3 ranges connected, as do A and C. Likewise, B and C. So our maximum number of ranges between any 2 phases is 3. This is easy to see when you only have 9 ranges and can draw it out plainly like this. But what if you have a multifamily building with, say, 40 ranges? Well, you're going to need a formula to use. And I've put together such a formula for that very reason. I'll explain this table a little bit now, but it'll make more sense once we start applying some examples to it. What we're essentially doing here with this formula is sort of creating an imaginary single-phase scenario. So we're kind of asking ourselves, if this were a single-phase system, what would the equivalent number of these ranges be? Then once we find that number, we plug it into table 220.55, get our demand, and then convert it back to 3-phase for our final value. Now I simplified this table into just 2 columns, covering the most major of the divisions, ranges at or under 12 kW, and those over 12 kW. Now to do it justice, it would have needed to be about 5 columns in order to cover each minor division more clearly, and maybe I'll do that for 2026. But because of this simplification, you're going to need to remember some of the steps that we've already covered earlier in this video, as they aren't specifically pointed out in the table. That being said, as we go through some of the examples, I'll make sure to call attention to each step as it is relevant, so don't panic. Now looking at the left column first, this covers ranges at or below 12 kW. We take the number of ranges and divide by 3. We round up our answer if needed and multiply by 2. That gives us what you might call our single phase number of ranges. What we do with this number depends on our range sizes. Notes 2 and 3 of table 220.55 dictate how we apply them. The default I put into this formula is for ranges between 8 3/4 and 12 kW of equal rating. Therefore, we apply that new number to column C of table 220.55 and then multiply the value in the column by 1.5. Now multiplying by 1.5 is the same as multiplying by 3 and dividing by 2. So we're simply reversing the process and taking it back to a three-phase system again. Remember up here, we divided by 3 and multiplied by 2. Now we're just doing the reverse by dividing by 2 and multiplying by 3. And then this gives us our total final demand value. Now the right column is very similar for ranges over 12 kW, but we have to apply the formulas from notes 1 and 2 of table 220.55. Recall these formulas from earlier. If we have ranges that are all the same kW value, we use the note 1 formula. If we have ranges of varying values, we average them first with the special 12 kW minimum value and then use the formula. Refer back to slides 13 and 14 of this video to see that again in detail. And that's how we calculate one-phase ranges on three-phase feeders. Now let's take our example and run through it. Here we have our 9 ranges at 9,000 watts apiece, only this time they're on a three-phase feeder. So we just need to plug in our data to the table, and since our ranges are less than 12 kW, we will use the left column. We have 9 ranges divided by 3 equals 3. Round up if we need to, which we don't, and we get 6. So our single phase number of imaginary ranges is 6. Now we go to table 220.55 and go down to 6 ranges. That gives us 21 kW for our value. Now that we have our demand rating, we have to convert back to three-phase. That means dividing by 2 and multiplying by 3, or simply multiplying by 1.5. And that gives us 31.5 kW. And since our ranges fall in the column C, we can skip this next line. So our total demand for 9,000 watt single phase ranges on a three-phase service is 31.5 kW. So now we see how to calculate a three-phase service with single phase ranges. Okay, in case it's easier to get your head around the way the single phase connections are made to a three-phase feeder, here's another way to look at it. We've got our 3 phases, A, B, and C. We have 3 ranges connected between A and B, 3 connected between A and C, and 3 connected between B and C. That might be helpful for some folks to see it a different way. Now also, you can go to the back of your codebook to Informative Annex D and see an example that they'll give you that incorporates single phase ranges on a three-phase service. Now here's a snapshot of it, but they don't really explain it in much detail. And then last of all, here again is that table with the formulas for calculating single phase ranges on a three-phase service, just for your reference. And that does it for range calcs. Thanks for watching, guys. If you found this helpful, please give it a like, and please subscribe to my channel. That'll really help me out a lot. Appreciate that. Please check out that channel for many other videos. I have single family dwelling, commercial, multifamily, dryer calcs, non-coincident loads, all kinds of different calculations. So please check that out and see what else might be helpful to you. And we will see you on the next one.